because these two are getting. Oh, 1 minute. Would it be the other way around? Because the heat was mixing temperatures.
Here's my answers. The y-axis is labelled temperature, the x-axis is labelled time. The cooling curves are curves which are decreasing in temperature, and the heating curves are curves which are increasing in temperature. And I've put a title here, Heating and Cooling Curves for Different Size Outer Beakers. But I think what we also need to add is that those two curves there are for the small outer beaker, and those two curves there are for the large outer beaker.
Not sure.
Are you guessing?
Yeah.
Well, what do you think steady temperature means?
Steady temperature means a temperature that is basically always the same.
Well, the answer is yes, a steady temperature is reached in both cases, but when the outer beaker is bigger, the steady temperature is lower.
Yes, but when the outer is a steady temperature reached in both cases. Yes, but when the outer beaker is bigger, the steady temperature is lower.
Okay, now what I imagine you've got in front of you is a whiteboard or squared paper with a graph, some labels on it, and I'd like you to go back to your desk now and copy that up neatly in your books. And, do it properly with a ruler, and then could you write an explanation of what the graph is about, so when you come to revise from it you'll have some idea, because you'll forget by then. Now, as an extension exercise, could you please also predict what the two curves would look like, the heating and the cooling curve would look like for a really big outer beaker? What would the graphs look like if I press this button here and it was a really large beaker? Now all of this I suppose will take about 15 minutes or so. So cover teacher, pause the video here and then call them back when you're ready. Thanks. Okay, back on me, and I'd like to go through the task I set you a little while ago. You won't need your whiteboards now, so just put them away, stop you fiddling with them. You won't need those anymore. Now, the task I set you, the extension task, was what would happen if you had a very, very large outer beaker of water, like this one. Look, it's so big, it's gone off the edge of the page. Now, I'm going to just press run here, and we'll see how we go. Look at that. Look, that's important. The outer beaker has changed temperature. It has increased in temperature, but by so little it doesn't even show up on the graph. It's hardly increased at all. The inner beaker has got colder, but the outside temperature, because there's so much of it, so much liquid there, it hasn't increased in temperature at all.